Welcome to T1 Day 13 of Honors Precalculus. Today we're going to be expanding the set of numbers we look at to the complex numbers. Exciting! And talking about the fundamental theorem of algebra. Let's get warmed up. First, we need to find an equation of a polynomial in standard form, that's descending powers, given this information. So the first thing it says, f of negative 2 is equal to f of 1 is equal to 4, and this is the key, equals 0. So it's basically telling you 4 points, or 3 points. It's telling you that when x is negative 2, the output is 0. When it's 1, it's 0. And when it's 4, it's 0. What's really cool about that is that because those zeros happen, you know that x plus 2 is a factor, x minus 1 is a factor, and x minus 4 is a factor. These are all factors. So that means that the polynomial we're looking for, it's going to be some f of x. It will have x plus 2 times x minus 1 and x minus 4 in it. They have to be glued together like that. And the only thing that can change is there can be an a value, some constant in front. And the thing that will fix what that a value is some other point that isn't a 0. So that point right there is when x is negative 4, the output is 40. So to solve for the a value, all you need to do is you need to plug in 4 right here, negative 4, excuse me. You plug in negative 4 for x and solve for the a value. So the 40, that comes from here, is going to equal a times negative 4 plus 2, negative 4 minus 1, negative 4 minus 4, like this. And then you clean it up and you get 40 is equal to a times negative 2 times negative 5 times negative 8. So you get a is equal to 40 over negative 2 times negative 5 times negative 8. And that's going to be 40 over 80 is equal to, negative 80 is equal to negative 1/2. So that tells us our final polynomial is going to be f of x is equal to negative 1/2 times x plus 2 times x minus 1 times x minus 4. And this is technically a polynomial that fits all of the things we want it to, but it says they want it in standard form, meaning we need to multiply this out. And when you multiply this out, you have to do it very, very carefully. Let's do those two first right there. So we have negative 1/2 times, we have x and minus x, so we have x squared minus x plus 2x minus 1. So that's the first two multiplied together like that. I would recommend cleaning it up a little bit first. So you have negative 1/2, you have x squared plus x minus 1, x minus 4. You have to be super, super careful about this because if you miss one thing, it could be wrong. And I could make a mistake, and you'll find it, and then you'll tell me about it. So I'm going to take the x and multiply it in by all of these. So I end up with x cubed plus x squared minus x. And then I'm going to take the negative 4 and multiply it by all of those. So minus 4x squared minus 4x plus 4. And now we need to combine like terms. And what I've done here is I've highlighted the like terms. So you have negative 1/2, and there's only 1x cubed. But then these two is going to be minus 3x squared. And then you have these two, so minus 5x. And then you're going to have plus 4, like that. And look at that, you already caught a mistake probably, because right up here, this should have been a minus 2. And when that's a minus 2 right there, this turns into, instead of plus 4, it turns into plus 8. So that actually should be a plus 8. And then this one right here will actually turn into, I've got to correct that, minus 2x right there. Woo, nasty stuff here. So then this turns into minus 6x. Now we multiply that negative 1/2 in and end up with negative 1/2 x cubed minus, it turns into plus 3 over 2 x squared plus 3x minus 4. This is in standard form. So as proven by the mistakes even I made, you have to do this really carefully, really carefully, really carefully. Now, I'll set this one up for you. This tells you it equals 5. All of these equal 5. So how do we go about doing that? Well, we know that these right here, when they multiply together, these factors, they create something that when you plug the numbers in, they all come out to be 5. So how do you do that? Well, the x minus 3, the x plus 4, and the x plus 6 are all made by these three things right here. And the a does go out front, but now because it's 5, you put a plus 5 right there. So this right here is going to be our function. Look what happens when you plug in 3 into here, this whole thing goes away. When you plug in negative 4 right there, it goes away. When you plug in negative 6, it goes away, leaving you with just 5. So it's very similar to what we just did. Now we take this point right here and we plug it in. That point is 1, negative 79. So you have negative 79 is equal to a times x minus 3, x plus 4, x plus 6 plus 5. You subtract the 5 if you want to isolate, but now we want to plug in 1 for x right here, the 1. So we plug in the 1. You can do it in 2 steps. It's fine. So negative 79 is a times 1 minus 3, 1 plus 4, 1 plus 6 plus 5. And when you do this out, you end up with a is equal to 84 over 70, which simplifies to 12 over 10, which simplifies to 6 over 5. I like leaving it like that. So the polynomial we have is f of x is equal to 6 over 5 times x minus 3, x plus 4, x plus 6 plus 5. Now if I wanted it in standard form, you'd have to multiply this out. I'm not going to do that right now, but I would highly recommend doing that because I might pick it for the quiz, maybe, possibly, hint, hint, probably will. What's really cool now is that we get to expand the type of numbers we look at to the complex numbers. Up until this point, all the numbers we've looked at are on the real number line. They all exist on this line. We're going to add a dimension called the imaginary plane, not imaginary plane, the imaginary axes. Complex numbers are made up of all the real parts and an imaginary part, and they are in the form a plus bi, where a is the real part and bi is the imaginary part. So we get to play around with something that functionally is another variable, but it is a number. The definition of I is the square root of negative 1. You need to memorize that and know that. When you're playing around with them, though, you get to treat them just like you would an x or a y as a variable. So for example, right here, if we're adding 2i plus 2 plus 3i plus 5 plus I, each of these is a complex number. This is a complex number right here, but 2 and 5 together is 7, and then 3i and 1i is 4i. So it's as simple as adding things together right there. What about over here? You multiply it out. 2 times 5 is 10, 2 times I is 2i, and then 15i, and then 3i squared. Like terms, 10 plus 7i plus 3i squared. But the key is I is equal to the square root of negative 1. So I squared is the square root of negative 1 times the square root of negative 1, which is negative 1. This is really important. The square root of 2 times the square root of 2 is 2. The square root of 3 times the square root of 3 is 3. The square root of a table times the square root of a table is a table. So one thing you need to remember is I squared is negative 1. So this right here is equal to negative 1, which means that you have 10 plus 7i plus 3 times negative 1, which is 10 plus 7i minus 3, which is 7 plus 7i. So you have to simplify carefully. That's multiplication. What about squaring? Well, that's multiplying it by itself, so it's this, the same thing, twice. Same thing twice. And you just have to keep track. 1/2 times 1/2 is going to be 1/4. And then 1/2 times this is going to be root 3 over 4i. And then you do this and you end up with plus root 3 over 4i. And then you do this, root 3, you have root 3 times root 3, so it's root 3 over 2 squared I squared. Those get squared. You have to be really careful. So first you have this 1/4, which has no other terms like it, so it stays like that. And then you have 2 of these, so it's 2 times root 3 over 4i. This gets squared. Root 3 times root 3 is 3. 2 times 2 is 4. I squared is negative 1. So what do you end up with? 1/4. The 2 cancels there. 2 plus root 3 over 2i minus 3/4. You do have like terms now, so you end up with negative 1/2 plus root 3 over 2i. This seems kind of random, but these numbers, if you've taken trig, you might know that they come up in trig. The last thing here, when you have dividing complex numbers, 5 plus I, 2 plus 3i, you're going to multiply by a form of 1, and this is where the conjugate comes into play. You're going to do the conjugate of the denominator right here. That is just a form of 1. So instead of 2 plus 3i, you multiply by 2 minus 3i over 2 minus 3i, and you have to be careful about multiplying this out. On top, you end up with 10 minus 15i plus 2i minus 3i squared. And on the bottom, you end up with 4, that's 2 squared, minus 6i plus 6i, so we did those, and then minus 9i squared. What happens here? You end up with 10, and then you have like terms right there. So 10 minus 13i, and this is negative 1, so that turns into plus 3, over, well, those cancel, 4 minus 9i squared, but I squared, remember, is negative 1. So what do we end up with here? 10 minus 13, oh, well, we have this and this is 13. So we have 13 minus 13i over not 4 plus 9. So that's 13 minus 13i over 13. What does that simplify to? Well, that's 13 times 1 minus I over 13. It cancels all the way to 1 minus I. It's really cool when that happens. It's not always that nice, but in this case it is. So here's where we get into the fundamental theorem of algebra. A zero of a function, as you know, is a number, real or complex, so it could have an I in it or not, that makes the function equal 0. An x-intercept of a function is a real number that makes the function equal 0. This is the key. An nth degree polynomial will have exactly n0, but maybe less x-intercepts, because it's a real 0 if it's an x-intercept, but if it doesn't have to have all real intercepts. Some of them could be imaginary. What that means is, if you're looking at this polynomial, the degree of this polynomial is 5, which is right there, meaning there are 5 zeros. There are 5 things that make this equal to 0, but they may be real, but maybe they're not. They could be imaginary, but they're all complex. So all of the answers will be of the form a plus bi. Some of them won't have that. It'll just be 0, and they'll be just the real part. So how do you go about doing something like this? Well, the key phrase here is find all the zeros. And if you don't have anything, it's very hard to start this. But it says use your calculator. And if you graph this, it'll show you that there are 3 x-intercepts, negative 2, 0, 1, 0, and 4, 0, if you use your calculator. And that right there is the starting point. So if you know, for example, 1 is a 0, you know that the factors are x plus 2, and the other factor is x minus 1, and the other factor is x minus 4, times some other polynomial equal to this thing right here, this polynomial right here. We're trying to find the rest here. Because this is to the 5th degree, we know that this is going to be a quadratic. But how do we do that? Well, we know that p of x will equal the original polynomial divided by all of these things. So what we're going to do is divide them one at a time. So what I mean by that is, since they're all linear, we're going to use synthetic division, which we already know. So let's do 1. I like 1 as a number here. So 1, and what are the coefficients of this right here? They are 1, negative 3, negative 5, 5, negative 6, and 8. So checking that 1, negative 3, negative 5, 5, negative 6, and 8. Remember what we do is we drop this first one down, we multiply by this, it's 1, so it's just going to be 1, you add them, negative 2, negative 7, negative 7, negative 2, negative 2, negative 8, and 0. What you then can do is these numbers that you've ended up with, you can then do synthetic division again with the next one. We just used 1, so let's use 4 now. We'll do 4 on this. You get 1, multiply, you get 4, add. So it's going to be 2, 8, 1, 4, 2, 8, 0. And then you're going to do the last one, which is going to be using the -2. We'll do that in blue. So -2, you do it again on these. So you drop this down, you get 1, -2, 0, 0, 1, -2, 0. We ended up with 0, which is very good. So what's that mean this last quadratic is? The last quadratic is therefore that's the constant, the x, and the x squared. So that's x squared plus 1. What that tells us is that this polynomial right here is x squared plus 1. It tells us that the original f of x is equal to x plus 2 times x minus 1 times x minus 4 times x squared plus 1 equals this. Well, we already know the zeros from here. That's -2, 1, and 4. What about this? X squared plus 1. When does that equal 0? Well, that's when x squared is equal to -1. Take the square root of both sides and you get x equals plus or minus the square root of -1. Well, the square root of -1 is I, so it's plus or minus I. So what are the 5 zeros? What are the 5 zeros? They are those I0 and -I0. These are imaginary, and we found them right there. For these, to find them in standard form means just multiply out. So multiply these out to find them in standard form and identify the zeros of the function and the x-intercepts. So you multiply them out. You have the zeros when they're in factored form. So here, for example, x is equal to 2i and x is equal to -2i. And when they're factored here, you have x equals 3, -3, I, and -I. So you can multiply these out, and to do intercepts, the y-intercept, remember, is when x is 0, and the x-intercept is when y is 0. You've done that many times. I'm not going to do it again, but you should do this out if you need to. So another thing you could be given is a polynomial in standard form of minimum degree, given that these are zeros right here. These are zeros. So what that means is if -3 is a 0, x plus 3 is a factor. If x equals 4 is a 0, x minus 4. And then for the next one, if 2i is a 0, x minus 2 plus I, 2 plus I is a factor. So what you then can do is think to yourself, if this is a 0, if this makes it 0 right there, the 2 plus I, one thing to add in is that 2 minus I must also be a 0. They're always paired up. 2 minus I must also be a 0. It must also be there. If 2 plus I is there, 2 minus I must be there. So another factor is x minus 2 minus I. So what you do to find this polynomial, you literally, this is it right here. This is it. But to write it in standard form, you need to multiply it out very, very carefully. Please do this on your own and show that this multiplies out to x to the 4th minus 5x cubed minus 3x squared plus 43x minus 60. You'll notice that there's no i's in it. Remember, I squared is equal to -1, and all the other i's are going to cancel out. So multiply it out carefully. For example, multiply out these two first, maybe multiply these out separately, and then multiply it. But this is FOIL. Be very, very careful. And you might have been wondering why, if 2 plus I is a 0, 2 minus I has to be 0. It's because of this theorem right here, which says that if a plus bi is a 0, a minus bi is 0, and vice versa. So if it's a minus bi, a plus bi.